Hello, Dr. Ron Eaglin here, and this is part of Programming for Engineers. And this lecture is going to be, this video is going to be on using some of the libraries and solving another one of the engineering type problems that we would typically solve. And the problem that we're solving is a classic problem here. We're going to solve the intersecting trajectories problem. It's a very simple problem because suppose you shoot a ball up in the air at an angle of 80 degrees and another ball up in the air at the angle of 20 degrees, where would their trajectories intersect? And this little piece right here kind of shows you kind of what that little intersection would be. Now, of course, there's obviously angles where they would never intersect, but the reality is if that you've got one that you shoot up between an angle of 0 and 45, and another one that you shoot up between an angle of 45 and 90, except for the extremes, they're likely going to have an intersection point. But what we want to do is we want to use Python programming to solve it. And in this case, we're going to go ahead and actually use some of the libraries because we could do this mathematically or trial and error using techniques that I've shown you in the past. But this one, we're going to actually use a Sympy, and we're going to use the solve function of the Sympy library. So, and here's one thing I want to do. I want to show you the code, but first thing is when you use a library, and you're planning on using a library in your Python code, realizing that you're probably going to want to reuse Python code, it's a good idea to put the documentation of the functions that you're using into the comments of your code. What that allows you to do is when you come back and you look at the code later and you're going, well, exactly how did I do that? It's going to be able to help you go through that. So the first thing that you're going to do is we're going to define the variable x using the symbol function of the Sympy library and the symbol x. So x is the symbol x. Well, what does that do? There's a whole lot of stuff behind the scenes. Not going to bog you down. Read the documentation. But the reality of what it's going to let us do is actually use the solver functions to optimize other functions. In this case, what we're going to do is find the roots or where it's 0, but do that using the variable x as the variable that is the one that you're going to find the root of for the function that you're going to set to 0. It's going to be a lot easier to see in code. So the inputs to the function are we've got two balls going up in air, and they're each going to have an angle, and we're going to have them both go at the same velocity. Realizing that you don't have to actually have them go at the same velocity, but you're going to do that. Then what we did is we wrote the function that has x in the function, which is important, x in the function that, because we're going to be passing it to x. And I realize that the x here and the x down here where you call it are actually different x's. It's just the one that's the value that's being passed. But what this does is it uses the formula from physics that figures out the y coordinate given the x coordinate, angle, and velocity. So if I give it the angle, velocity, and x, I'm going to get back y of the trajectory using the equations of motion. Got it? Not hard. And by the way, you can just look the formula up and write the function relatively easily, but you want to take a look at that. And this was actually one of the problems that one of my students solved for one of their homeworks. And what I did is I just made some changes to it to kind of simplify the whole thing. So now with this function defined, just get that. This function is defined. I can call it. And I can call it with different values. So what I'll do is I'll call it with the first angle and the velocity and the x, and then the second angle and the velocity and the x. So in other words, I'm going to have the trajectory of the y coordinate with an angle, velocity, and x, and a y coordinate with an angle of velocity and x, but the other angle. So now I'm going to get into the solver. And again, read the documentation. It's in Sympy. But what I want to do is I want to find the value of x where a minus b is 0. That's what I'm doing. In other words, I want to find the value of x where a is equal to b. And a is the y coordinate with one angle, and b is the y coordinate with the other angle. So when I find the y coordinate where the with the x. So I want to find by making those a minus b equal to 0. I'm finding the common y coordinate. So, and then once I've done that, I set that equal to a value. If you look at the documentation, you'll know that actually the solve function doesn't return a value, and it returns a list of information. But the element 1 of that is the actual x coordinate of where they intersect. So where the intersection will be. Okay, wow, that's a whole lot of information to digest. But again, I'm telling you to go out and research these. I'm giving you ways of doing this, but I want you also to see my technique. It's very important. So then what I do is I say, you know what? If I have the x coordinate where the trajectories intersect, it's easy for me to then calculate the y coordinate because I just put in y coordinate 1 and y coordinate 2, and they should be the same, right? Because I'm passing in the x coordinate, and if the angles, we're finding the intersection. Then the last thing I'm going to do is down here is I'm actually going to print it. I'm going to create xp for a range of x variables, y1 and y2, and I'm just going to use matplotlib. I'm going to go ahead and calculate. I'm going to make 10 points along it. I could just have done as many, and I'm going to calculate the location, which is basically going to be the x coordinate is the largest coordinate because it's going to go from 0 to x coordinate. That's where the ball actually goes along the x-axis, or whatever you shoot up is 0 to x coordinate. And so then I can calculate the xt by saying x coordinate divided by times I divided by 10, and the range is 0 to 11. And then I just basically put together the two arrays, and then I plot both of them on the same plot. So let's run this baby, and I'm going to go ahead and hit run, and I'm going to bring this over here so you can see it. Whoops, that went the wrong way. Okay, so I'm going to bring this over here so you can see it, and it's going to ask me for an angle, so let's give it 125, and it's going to ask me for an angle. Let's give it 175, and let's give it a velocity. Let's say 20, and voila. It calculates the for that velocity. It's going to calculate the x location of the intersection, the y location of the intersection. You can actually see the plots of the two things because I made the plot. And you should notice that the y location here is almost exactly the same. In fact, you got to go all the way down to those last decimal places to see the difference. So that's it. Now, what we have learned here. First, you've got an incredibly powerful library to solve the situation where those coordinates are equal. That's an amazing thing. Use it. Okay? And really, when you're out there and doing engineering work, you owe it to yourself to learn the capabilities of the different types of libraries that are available to you. And I'll tell you, Sympy, Sympy, and NumPy have an insane amount of power and the functions that they provide to you. Then the rest of it is the simple stuff. Writing a function, okay? Writing a function, and you should know this by now, the function has these variables. These variables are scoped inside the function. In other words, they have the values that you pass to them inside the function. It's Python, so everything is tabbed over. So if you call the function with one set of numbers, or you call the function with another set of numbers, those numbers are passed, the calculation, and then the number that you use in the return is returned back. Now, I didn't go into a lot of detail of the solve because what I want you to do is I want you to go out and look at that. Look at the Sympy documentation and look at what's possible. And also, just learning from other people the approaches that they take to solve these kinds of problems, because I could have easily done all this by hand, but I didn't because I had something that would do it for me. So thank you very much, and good programming.